In this video, I'm going to introduce you the way of finding the intersection point, the point of intersection of the two lines in space, alright, a three-dimension line. So they're given a two-vector equation of a line. So how to find the intersection point between two lines that are non-parallel, they are not skewed. So now for this case here, so if you want to find intersection point between two lines, the first thing that you must do is write the line in the parametric form. So for example, this case here, your parametric form will be, okay, you can write as I with the I, right? 2 plus with lambda, right? 2 plus lambda. So, and the Y will be 1 plus with 3 lambda. And the Z will be according to K, so -1 minus with 4 lambda. So first you have rewrite everything here in term of in parametric form. So I name this to be equation 1. As you know that you have a knowledge that if you want to solve a point of intersection, usually we were doing simultaneous equation, right? But this is the way when we're solving between two lines in space, the intersection point. So and for this is also we can rewrite as x, y, z. X here will be -1 plus with -2 mu, right? 2 mu, followed by your y will be, there are no y here because no j component, so this is 0, right? 0j, this is 0j plus with 2 mu, right? 2 mu, and for the z will be -2k, -2 minus with 5 mu, right? So then this will be equation 2. So why I'm going to write this in the parametric form? As you know that, what is the meaning of intersection point? Always, beside doing, you must know, intersection point means they have the same value of, they share the same value of x, same value of y, and same value of z. Where they intersect means this point is on both of the line, right? This point is on the line 1 and also on the line 2. So it means the x, y, z value will be the same. So I can say that the x value here and the x value there will be the same. That's the first thing that I should do. So 2 plus lambda. So for x component, right? For x component, so I can say that 2 plus lambda is the same as -1 minus 2 mu. This is a very important relationship. Alright, so okay, so I get the equation from this x component here. So where I will have lambda plus with 2 mu is equal to -1, -2, so -3. So this will be my equation A. Okay, I label this to be A, equation A. So I need another equation, so I can say that the y value also will be the same. So this will be 1 plus 3 lambda is equates to 0 plus 2 mu. So if I writing this 3 lambda minus with 2 mu, right, will be the same as -1, equation B. So later on I can actually get another equation, right? So even though I just need 2 equations, but the third equation is very important here. But I'm not going to further discuss here about, because they are lines that will not intersect. Alright, there is a further knowledge from for linear algebra. So as this for this, and we have z value also will be the same, as this 4 must be the same. So it's the same as -2 minus with 5 mu. For this, I will putting this as a extra equation, alright, an extra relationship, okay, extra equation to verify the value of lambda and mu, alright. If the value of lambda and mu you substitute here, and you get both sides will be the same. So it means that the line are actually intersecting, alright. So, okay, let's find what's the value of lambda here. I can using substitution. So where I can rewrite lambda to be -3 minus with 2 mu, right? So lambda is negative 3 minus with 2 mu. And I substitute this into the lambda here. Alright, negative 3 minus with 2 mu. So I will getting 3. My lambda can replace with negative 3 minus with 2 mu minus with 2 mu equals to negative 1. Right? So just calculate negative 9, negative 6, negative 2 mu equals to negative 1. So as you're getting negative 6, negative 2, you have negative 8 mu, and negative 1 plus with 9, you have 8, and finally you have your value of mu to be negative 1. Right? So mu will be negative 1. So means that and this value of mu, you can finding the value of lambda here. So substituting back into here, you will finding the value of lambda, which will give you negative 3, negative 2 times with negative 1. Right? So which also giving you negative 3 plus with 2, which is also negative 1. Right? So negative 1 and negative 1. But you want to find, what you want to find is the point of intersection, right? You want to find the point of intersection between the two lines, right? So with this, before you finding the intersection point, the third equation is very important here now. It's for you to verify whether it satisfies both sides or not. So if satisfies both sides means that it's passing the test, right? Passing through the test. Means that the value of lambda and mu can be substituted into the x, y, z here to finding the coordinates, okay, the point of intersection. But you have to verify with this. So the lambda, okay, let's look at the left hand side here, right? The left hand side here. So negative 1 minus with 4 lambda. So the lambda value here is negative 1, which gives you negative 1 plus 4, giving you 3, right? And go for the right hand side, which will be negative 2 minus with 5 mu, which is negative 2, negative 5, and mu will be negative 1, which also giving you 3. Can you see that? Both satisfied, means 3 equals to 3. Means that this value is valid. It's valid as to find the coordinates, the point of the intersection. So how to find the point of intersection? Very simple. Alright, okay, let's look at it. Alright, how to finding the point of intersection? Very simple. So you can either substitute the negative 1 into this parametric equation, you can get the coordinates, the point. So where if lambda, right, lambda is negative 1, so the value of x will be, so you are taking 2, right, 2 minus with 1. So 2 minus with 1, you have 1, right? And the y will be, lambda is negative 1. So 1 plus 3 negative 1, 1 plus 3 negative 1, which will giving you negative 2. And the value of z will be negative 1 minus 4 with negative 1. So negative 1 plus 4, you have 3. So the point that you get will be 1, negative 2, and 3. Alright. You can also actually substitute the mu equals to negative 1, either one, into this equation. Right? So if mu is negative 1, it's the same, right? Either one. So the x value here, you will try and see, negative 1. So if you put negative 1 here, negative 1 plus 2, you are having 1, right? So your y value, so if mu is negative 1, so you are getting negative 2, right? They will be the same because they are intersection point. So z, you putting mu is negative 1, right? So be negative 2 minus with 5 times negative 1, which will still giving you 3. So they have the same coordinate, same point, because why? This is an intersection point, right? So it means that the intersection, the point of intersection of these two lines is 1, negative 2, and 3, right? 1, negative 2, and 3. But this is a very basic examples for point of intersection, because there is a line in space where they does not intersect, or they intersect infinitely, all right, they have infinite solution, all right, that going to discuss further in university level calculus, all right. But for your knowledge now, this is the way we're finding, the basic way of finding the point of intersection of two lines, all right. So that's all for these examples. Hope you understand.